Hey everyone, let's jump right into this explainer and explore the absolute sheer physics, the geometry, and the human reaction times it actually takes to manage the massive invisible safety bubble around an 80,000-pound commercial vehicle. I mean, when you're driving a machine of that magnitude, you aren't just driving on a road, right? You are constantly calculating time, speed, and distance to literally prevent a catastrophe. So today, we're going to crack open the precise rulebooks and physical laws that professional drivers absolutely have to master just to keep all of us safe out on the highway.
Here's our roadmap for today. We've got 4 parts. First, the 15-second visual lead. Second, building your safety bubble. Third, the physics of stopping. And fourth, emergency triangle tactics. Okay, Section 1, the 15-second visual lead, looking into the future. We're starting at the absolute furthest edge of a truck driver's awareness here, focusing on why it is so critical to look far enough ahead. You see, because stopping or changing lanes in a heavy commercial vehicle takes an enormous amount of physical space, good drivers simply cannot just stare at the bumper right in front of them. They have to know what traffic is doing on all sides well in advance.
Now, a constant requirement of 12 to 15 seconds translates into wildly different physical distances depending on how fast you're going. The official guidance says you need to look ahead the exact distance you'll travel in that 12 to 15-second window. At lower city speeds, well, that's about one single city block. But out on the highway, that stretches out to a full quarter of a mile. If a driver isn't scanning that far ahead, they risk having to slam on the brakes or make a sudden lane change, which in a massive rig is just asking for a disaster. But hey, looking 15 seconds out doesn't mean you ignore what's right in front of your grill. The absolute best drivers are constantly shifting their attention back and forth, from near to far.
Moving on to Section 2, building your safety bubble and the 10-foot rule. Now we're zooming in from that distant horizon right down into the immediate bubble of space surrounding the moving truck. Managing this space is crucial on all sides. For example, to protect their right side and rear, drivers actually prevent right turn crashes by turning wide as they complete the turn. They intentionally keep the rear of their vehicle close to the curb just to block smaller, impatient vehicles from trying to squeeze in. But honestly, of all the space around a commercial vehicle, the area directly ahead is the most critical. Why? Well, accident reports show the vehicle trucks most often hit is the one right in front of them, usually just from following too closely. Because let's face it, smaller vehicles can stop way faster than heavy ones. So, the crucial point for this whole section boils down to this single number: 1. Drivers must leave at least 1 second of following distance for every 10 feet of vehicle length when they're traveling below 40 miles per hour. This is literally the foundational formula for the safety bubble. It buys the driver the time to think and the physical space to take action when things go sideways on the road ahead. Let's walk through how this math actually plays out in the real world. A 40-foot truck traveling under 40 miles per hour needs 4 seconds of space. Simple enough, right? But here is the kicker. If you are going over 40 miles per hour, you've got to add an additional 1 second just for safety. So a 60-foot rig traveling at highway speeds requires a massive 7-second gap. Now, how in the world do drivers calculate that on the fly? They wait until the vehicle ahead of them passes a shadow, maybe a pavement marking or a clear landmark, and then they start counting 1001, 1002. If they reach that same landmark before hitting 7 seconds, they are way too close and need to back off immediately. All right, Section 3, the physics of stopping, force and reaction. Let's transition into the sheer physics of what happens when that safety bubble actually gets breached and the truck desperately needs to stop. You know, when you double your speed from, say, 20 to 40 miles per hour, the striking power of your vehicle is suddenly 4 times greater and the braking distance is 4 times longer. High speeds dramatically, and I mean dramatically, increase both the severity of crashes and the stopping distances required. So, bringing a massive truck to a halt isn't just one simple action. It's this complex, multi-stage physiological and mechanical event called total stopping distance. And it breaks down into 3 very distinct steps. First up is perception distance. That's the time it takes from when your eyes see a hazard until your brain actually recognizes it. Second is reaction distance. That's the distance you travel before your foot physically stomps on the brakes. And third is the braking distance itself, which is the actual distance the vehicle covers while those brakes are engaged. Let's walk through the absolutely staggering math on this. At 55 miles per hour, we add 142 feet just to perceive a hazard. That takes an alert driver about 1 3/4 seconds. Then we tack on 61 feet just to physically react, taking another 3/4 of a second. Finally, we add 216 feet to actually brake the truck. Add all that up, and it totals a minimum of 419 feet.
To put that into perspective, that is significantly longer than an entire football field, just to come to a complete stop from 55 miles per hour under ideal, perfectly dry conditions. And if that road happens to be wet, yeah, that distance can easily double.
Now here's where the physics gets wonderfully counterintuitive. An empty truck actually takes longer to stop than a heavy, fully loaded one. No way, right? You'd totally think a lighter truck would stop faster. But the brakes, the tires, the springs, and the shock absorbers on these heavy vehicles are specifically designed and engineered to work best when the vehicle's fully loaded. An empty truck has significantly less downward force, which simply means less friction and less traction on the road, ultimately leading to a much greater stopping distance.
Section 4. Emergency Triangle Tactics. Handling Stationary Hazards. Finally, we need to look at what happens when the truck is completely stationary, but it still poses a massive spatial hazard to everyone else on the road. The reality is, you absolutely cannot trust your taillights to give adequate warning to approaching traffic. Other drivers frequently crash right into the rear of parked commercial vehicles simply because, from a distance, they think the truck is still moving normally in its lane. Because of this deadly optical illusion, the very moment a truck breaks down on the shoulder or the road, the driver is on a strict 10-minute countdown to establish a brand new stationary safety bubble using some real geometric precision. They have to get those reflective warning devices out immediately. And here's a super critical survival tip from our sources. When putting out these triangles, drivers must always hold them between themselves and oncoming traffic. That way, approaching vehicles catch the reflection and can swerve to avoid hitting the driver while they're walking on the side of the highway. Check out the distinct spatial mapping required here, which totally changes based on the type of road. On a one-way or divided highway, drivers have to pace out their triangles unidirectionally toward approaching traffic at exactly 10 feet, 100 feet, and 200 feet back. But if they're on a two-way or undivided highway, they've got to secure both approaches. That means placing one triangle within 10 feet of the front or rear corners, 100 feet behind the vehicle, and 100 feet ahead of the vehicle to warn oncoming traffic. And if there happens to be a hill or a curve obstructing the view, that rear triangle might need to be pushed back as far as 500 feet. All right, let's wrap this explainer up with a pretty stark reality check. Research shows that just dialing a mobile phone takes a driver's eyes off the road for an average of 3.8 seconds. At 55 miles per hour, that literally equates to driving totally blind for 306 feet, which is basically a whole football field. Knowing that taking your eyes off the road for just a few tiny seconds eats up so much distance, and knowing that a heavy truck needs at least 419 feet just to come to a stop, we really have to ask ourselves, how safely are we treating the physical space these massive trucks desperately require? Are you managing your own safety bubble out there and giving these everyday heroes the room they actually need to do their jobs safely? Keep that in mind next time you hit the highway. Thanks so much for joining me on this explainer, and hey, stay safe out there.